Welcome back. Of Code 2017, Day 12, Digital Plumber. Walking along the memory banks of the stream, you find a small village that is experiencing little confusion. Some programs can communicate with each other. Programs in this village communicate using a fixed system of pipes. Messages are passed between programs using these pipes, but most programs aren't connected to each other directly. Instead, programs pass messages between each other until the message receives the intended recipient. For some reason though, some of these messages aren't ever reaching their intended recipient, and the programs suspect that some pipes are missing. They would like you to investigate. You walk through the village and record the ID of each program and the IDs with which it can communicate directly. You puzzle input. Each program has one or more programs with which it can communicate, and these pipes, if 8 says it communicate with 11, 11 can communicate with 8. You need to figure out how many programs are in the group that contains program 0. For example, suppose your door-to-door like a traveling salesman, record the following list. 0, 2, 1, 1, 2, 0, 3, 4. Okay, in this example, the following programs are in the same group that contains program 0. 0 by definition, 2 directly connected, and then 3 via program 2, and so on. How many programs are in the group that contains the program ID 0? So we can go here and delete some stuff. This line start for each. We can just split this. A0 is B, A1, and then we split again, comma. We can get some. Do we need ints even? We don't care. We can just leave them as is. And we can just say connections equals mutable set pairs of int. And for each connection I find here, I just add B and it and B. Where's the not string? I didn't cast it as a string. I didn't cast it as an int, so it's a string. Then we have all the connections, I think. Okay, and then we just have to see. Have like edges in a graph and have to walk it. I wonder if there's an easier way. Well, let's just do it. if I use P, it's a bit short. I do want ints. P is int, and then this one is an int. And then we go. Visited is false. I don't know how to do the loop. Let's see. While done, I go visit. Current is also a mutual list of myself. So I just put current and visited connections, and then just walk there in all the directions I can. Oh yeah, current is actually 0. To use points. Yeah, and then I just have to do point here. This is 6 point. The whole point. Set. Set score. Let's use set. Then I do dot for each. I mean, do I want to visit again? Probably not. So I want to check all the connections available. If connection.x equals current, then I can go there. To y. And not in visited. And I can go there. This is the next ones. All of them. And then I'll just update code to be next. And then if something happens, I'm done. If I think if next is empty, I'm done. Something like that. Let's check it. Okay, I visited everyone except one. My size is 6, like in the example. Let's try this. This is 145. And that's it. Part 2. There are more programs than just the ones in the group containing program ID 0. The rest of them have no way of reaching that group and still might have no way of reaching each other. A group is a collection of programs that all can communicate via pipes, either directly or indirectly. The programs you identified just a moment ago are part of the same group. Now, you would like to determine total number of groups. One had 2 groups. How many groups in total? Okay, so we can just do the same thing that we did here again, just with all the remaining ones. I can do something like find group, return set of pointer group. Yes, of int. Then I can go and say all is all the distinct ones. Then found is immutable set. Found dot add all of the group. Then I have group num equals 0. So I kind of have to take one first. Then I find the groups for that guy. Add all of those that I found into found and then increase group num. And then I print group number, and that's 207. That's it. Okay, so let's talk through it. We started group at program 0 and find what group is it part of by just walking along all the possible edges and find which ones we end up visiting. So how it works is we have this function find groups. It starts as a position, say 0, and I have all the connections, which is all the connections from the input. So let's do the simple example. 0 is connected to 2, 2 is connected to 0, 2 is connected to 3, and so on. So all these connections are a fixed set of kind of instructions. So I start at 0, I say currently I can visit 0, so my group consists of 0. I've visited 0, and I mean the program ID 0. I'm not done. While I'm not done, I visit based on what I currently, where I currently am, what I have visited, and all the connections. Visiting is just breadth first search, where I go for each of the current program IDs that I have. And for each connection that exists, I check, is this connection relevant to me? So does the connection start with the same program ID as I am? And does it end with a program ID that I haven't visited yet? If yes, then I add the program ID that my connection leads me to my list of program IDs that I want to check next. And I return that. So that's one step of the breadth first search where I get all the kind of neighbors that I can visit based on my current set of positions. If next is empty, then I'm done. Otherwise, because I've visited everything that I can. Otherwise, all the ones that I just was able to visit in the last iteration to visit it, update current to be the next one. So I start from the next ones again, because from the current positions I already went through my neighbors, and then I just loop through that until I visited everyone that I can. And then I have visited, which is a set. So all the unique positions that I visited, I just return. So for part 1, I just do that for position 0, like this, and the group, and then I can print the group size, which is 145 for my input. Then I'm interested in how many groups are there in total. So this position 0 was just one group, but what I can do is keep track of all the possible program IDs and all of the ones that I have found and make a counter for the group number. So I check, just take any one program ID, find the group for it, all the ones that it can reach, which is also all the ones that within the group they can reach. Then I add all of the elements that I found in the group to a list of program IDs that I already found and increase my counter. So in the next iteration, I again take the first one from all of the ones that I haven't found yet, so all minus found, the first one, and find that group's program IDs. Add them again and increase my counter. At some point, found every group, even if it's just one in the group, one element, and my found has reached size of all, and then I can return the group num, which is 207. So that's it for day 12. Enjoy the rest of your day.